Hello math crew. We're going to be working with an equation of a parabola in standard form. The plan here is to do some work based on symmetry. The instructions read, find the vertex of the parabola without graphing. We'll start by finding the y-intercept and then find the symmetric point of the y-intercept, then find the vertex. In the end, they ask you to rewrite the function in vertex form. Be very careful. If you are in a section with me where I said don't worry about vertex form yet, then don't worry about it yet. If you're in a section where we are using vertex form, then of course you would go and complete that. And I'll show how to do that when we get there. They give you the function f of x equals x squared minus 6x plus 7. And they give you a template to work your way through this. The plan here is that we can see this first step, f of 0 equals 0 squared minus 6 times 0 plus 7. We can work out that arithmetic. This will be 0 minus 0 plus another 7. So that f of 0 equals 7. What you're actually doing there is locating the y-intercept. For the explanation, I'll write in locate the y-intercept by plugging in x equals 0. So we found the y-intercept. Every parabola has a y-intercept. The next thing we're asked to do is to find the symmetric point to the y-intercept, and that is the point that has the same height as the y-intercept on the parabola. 7 was the height of the y-intercept, and so 7 will be the height of the symmetric point. 7 equals x squared minus 6x plus 7. For an explanation here, find the symmetric point by using y equals 7 from the y-intercept. Now we have an equation to solve. 7 equals x squared minus 6x plus 7. We need to set this equal to 0 to get started with the solving. We'll subtract 7 from both sides. 0 equals x squared minus 6x. That statement, or that equation on the right-hand side, it can be factored. There's a common factor of x. 0 equals, pull out that common factor of x. X times x minus 6. Set each of your factors equal to 0. The first one is friendly. We get x equals 0. The second one, x minus 6 equals 0. Adding 6 to both sides gives us x equals 6. Those are the two solutions, the two x values on the parabola that would have a height or a y value of 7. In the explanation area, solve the quadratic equation for x in order to find the x coordinate of the, we're finding the x coordinate of the symmetric point. And we also find the x coordinate of the y-intercept, but we already knew what its x coordinate was. What we know is that 0, 7 is the y-intercept. I'll just make a note over here. 0, 7 is the y-intercept. And then 6, 7 is the symmetric point to the y-intercept. To find the x-coordinate of the vertex, we'll need to consider the y-intercept and its symmetric point. The vertex is exactly halfway in between these two. And so if we have an x-coordinate of 0 and an x-coordinate of 6, the halfway point would be x equals 3. If you are unsure on whether that's true or not, you can find the average of 0 and 6. 0 plus 6 divided by 2 would be 3, and this will be the x-coordinate of the vertex. To find the y-coordinate of the vertex, you'll take that value of 3 and plug it back into your original function. We end up with 3 squared minus 6 times 3 plus 7. When we work this out, this is 9 minus 18 plus 7, and I think this gives us negative 2. So here we're finding the y-coordinate of the vertex. We can now write the ordered pair for the vertex, and in our case, it is 3, negative 2. For an explanation, I'm just writing in that we're writing the vertex as an ordered pair. And so if you do need to find the function in vertex form, we'll do that here, but remember I said at the beginning that you might not be required to know about that just yet. Vertex form has this format: y equals a times the quantity x minus h squared plus k, where h and k go with the vertex of your parabola. For us, let's pretend that we don't know anything about a just yet, but we do know our vertex. We'll just substitute it in. So we'll get x minus 3 in parentheses, and that gets squared. And then the k value is negative 2. So far we have y equals a times the quantity x minus 3 squared minus 2. We can go grab our a value from our original function. In the original function, we had f of x equals x squared, which means our a value is just 1. And the a value stays the same between both formats for the quadratic functions. So our a is 1, and you don't even need to write it, you don't even need to write it out front. You can just have the assumption that it is there. And so y equals x minus 3, quantity squared, minus 2.